Hi guys, welcome back to the brand new episode of Virentech Automation. Today we are going to build an PLC trainer kit to perform various applications or various experiments in our educational engineering life. So we have used an PLC over here which is having 8 inputs and 6 outputs. It is of as shown in the video. These are the input and output terminals of the PLC. There is a switch to change the mode, to run mode and to program mode. So by using this clip we can change the mode of this PLC so as to program it using computer and in real time to run it in the normal mode. This PLC is fitted onto the
connecting clip with the plywood board.
These are the input output lines which are connected to respective devices. This is an serial port. The PLC has provided with serial port. We have used an USB to serial converter so that we can connect this PLC to our computer or laptop using USB. These are the input sections. We have used two push buttons and two toggle switches to give an input in various cases. Also we have used an proximity sensor which is of PNP type metal detector. This can also be connected in the system. We have provided these banana connectors in this system so that we can connect any appliance or any input or output device to any pin. So these are 8 input pins, X0 to X7 are the input pins of this PLC, and these are the output pins of the PLC. PLC is having 6 output pins which we have connected to a 6-channel relay module, and these are the output pins of that 24-volt relay channel. Each relay is having 3 output pins, that is common, normally open and normally connected. So 6 relay we have used in the system. So each relay is having 3 output pins. As per the requirement we can connect the devices to these common NO or NC pins of the relays. Relay 1 to relay 6 are the 6 relays. We have used a 24-volt relay module over here as the PLC is 24-volt operated. To give supply to this system we have used an 230-volt AC inputs which is connected to a 24-volt DC converter which will convert 230-volt AC to 24-volt DC. The 2 pins over here are given to connect this 24-volt to the external supply. Also we have used 24-volt to 12-volt converter, and these pins will give you a 12-volt signal. Also we have used a 5-volt converter which will convert the supply into 5-volt, and we can give the 5-volt to the supply pins of any device. Also we have provided AC outputs. These are 4 indicator lamps which are AC, which can be used as per the requirement. These are the 4 input connectors, and this is a common connector. So AC supply is having phase and line. So line is connected directly to the common, and phases are connected through the relays as per the requirement and circuit diagram. We can perform a traffic light application signal on this experiment setup. So that's why we have provided these 2 traffic signals, red, orange, green. These are the connectors to give input to the traffic light signal, which can be connected through the relays. Common of these indicators is connected directly. Next output devices are the motors. We have used stepper motor and a DC motor in this system. We have used 10 RPM gear DC motor over here which is having 2 input connect pins, M1 and M2. Stepper motor is having 4 step sequence, so it is having 4 input pins and 1 common pin. This stepper motor is 5-volt operated, so we'll have to give plus 5-volt to the red connector, which we have already provided onto the board. And the control pins can be connected through the relay, and it can be driven through the relays. We have also provided some additional features or add-on boards so that we can perform some additional experiments on this PLC board. These are the banana connectors we have made as per the requirement and as per the length required into the system. So as shown, it can be connected to any input output pins through these banana connectors, and we can operate the system. These are some add-on boards. This is an elevator board. It is prototype model of a elevator or lift. This small lift can be moved up and down using the DC motor, and we have inserted some sensors, limit sensors over here, and output input pins are provided onto the board. This is another add-on board which is having water level controller, high level switch, low level switch, and water pump is provided into the system. So let's test some applications on this kit. The first application is lamp on off using PLC and switches. So let's make the connections first. As all the connections are completed, now we'll just put the PLC into the programming mode and connect it with the computer so as to program it. So I have shifted the button towards stop mode, and now we will open PLC software, and I have written some ladder diagram already and just transferring it to the PLC. So it's transferred now, and I will put the PLC in run mode again, and after that it will run as per the code or ladder diagram inserted into it. So let's just test it. Everything is set, and we will now see the output. So as you can see, whenever I switch turn on and off, the light also turn on and off. So in this way we can complete this operation. Now we will see another example, which is the blinking of the lights or sequential blinking of the lights as per the switch pressed or the proximity sensor activated. So for that we will made necessary connections, and now I will put the PLC into the stop mode so that we can upload the new ladder diagram into it. So let's just upload it, and we will then see the operation of this application. I have connected the PLC to the computer, and I will just turn on the AC supply to the system. As from the LED we can see the PLC is turned on now. I will just made some settings. So I will choose the PLC, its module name, proper PLC and its module name. Then I will set the communication settings also. So here we can set RS232 communication type. Then I have selected the port and baud rate. Now I will upload the ladder diagram. I have made the ladder diagram already, and I will set it to PC to PLC mode. And now the ladder diagram is uploaded, and I will just put the PLC into run mode again so that we can see the operation of the application or the ladder diagram we have inserted. So as you can see, when I turn on the switch, I have connected it to the toggle switch. So when I turn on the switch, the light started blinking in sequential mode. I have connected it to the push button now. So when I press the push button, the lights will turn on and off. Now I will connect it with the proximity sensor. As you can see, Whenever the metal comes near, the lights turn off. Whenever the metal goes away, the sequential light turns on. So in this way we can control the operation. The third example is traffic signal lights. So let's make the necessary connections. As I have shown earlier, the system is having a traffic signal lights already into the board. So as you can see, red, orange, green and red, orange, green. The 6 lamps are there to show the true traffic lights. So let's make the necessary connections. I have connected the common line to the common line of the lamp from the AC supply. Then from the AC supply another point is connected to the normally connected point of the relays. So it will be connected to the NC. The common will be connected to each lamp. We have 6 lamps and also the PLC outputs are also 6. So that's why we have taken 6 signal lamps, that is 2 signals. I will connect each common line to the lamp connection. The common pin of all the lamps is connected to the common line of the supply, that is AC supply, because these lamps are AC lamps, and the phase line is connected to the NO of the relays. So normally there is no connection between NO and the common, so lamp will not be turned on. As per the sequence and timings we have set into this ladder diagram, the lamps will operate. So we'll just put our PLC into the stop mode so as to insert the ladder diagram into it. So I will turn on the supply to the PLC and we'll just put the code into it. So let's just transfer the code into the PLC, and we have inserted a start switch in the code. So we have connected the toggle switch, and whenever the toggle switch is turned on, the sequence will start. So let me just adjust the camera at one place and we'll start the system. First, a red lamp is turned on. The sequence has started now. Orange lamp is having light intensity very low, so I think camera cannot justice it, but now you can see the orange signal. Whenever red to green and orange to red. The sequence is like this: green, after that orange, and after that red will be activated. So now you can see the red will become green and the orange will become red. Yeah. So in this way, as per the traffic regulations and rules, the signal sequencing is done, and we have inserted that same signal sequencing into our ladder diagram and transferred that ladder diagram code into the PLC. The code will start only after the start switch has been turned on. In this way it will continue to operate. You can see in the fast mode. The another example is of DC motor. We will rotate the DC motor in clockwise and anti-clockwise, that is forward and reverse direction. The DC motor we have used in this kit is a 12 volt operated geared DC motor which is having 10 rpm. So to operate this motor we need to give a 12 volt signal to the system. For that purpose we will use two relays as a motor driver, and alternately we will turn on and off the relay to turn the motor in the forward and reverse direction. For that purpose we have connected DC 12 volt to the relays. We will connect negative terminal of the supply to the NC pin and positive 12 volt to the NO pin, and the common pins of two relays are connected to the motor pins. We will add the two switches, push button switches. One is for forward direction, one is for reverse direction, and we will write the logic into ladder diagram so that when we press the switch, one relay will turn on, so that particular pin become positive, another pin is already connected to the negative, so motor will rotate in forward direction. If you press the reverse switch, the motor will rotate in reverse direction. So let's just put the ladder diagram into the PLC. We'll select PC to PLC mode and the program goes into the PLC. Now I'll put the PLC into run mode again, and we will test the motor operation. For that purpose we need to press the switch. So now you can see when I press the switch, the motor will rotate in one direction. When I will put the another switch on, the motor will rotate in another direction, clockwise and anti-clockwise. This is a clockwise direction and anti-clockwise. Next example is of stepper motor. We will rotate the stepper motor in clockwise and anti-clockwise direction. Stepper motor is basically used to rotate the rotor shaft in particular angle. So it will have a stepping sequence. The stepper motor we have used here is of 5 volt, so we need to give 5 volt to the common pin of the stepper motor. The negative will be provided through the relays, so I will connect the negative of the supply to the NO pin of the relays. We will use 4 relays as a driver to operate this stepper motor. The 4 pins of the stepper motor, A, B, C, D, stepping sequence pins, I will connect it to the common pin of the 4 relays, and we will develop a ladder diagram so as to give a stepping sequence through these relays, and the motor will rotate. We will also use 2 switches, push button switches, so that we can use these switches to rotate the motor in clockwise and anti-clockwise direction. So let's just put the PLC into the stop mode and upload the code into the PLC. I have made a ladder diagram which will operate as per the switch pressed, and the sequence is given to the relays, and the relays will operate, and because of the relays operation the sequence will be given to the stepper motor, and the stepper motor will also operate. I have uploaded the code into the system, and now I have pressed the clockwise button, so motor is moving in the clockwise direction. It is a micro stepping sequence motor, so it will rotate with a slight angle movement. I will make it the video fast so you can understand it well. So now you can see it is rotating in clockwise direction. Now I will put off the clockwise switch and turn on the anti-clockwise switch so that the motor will start rotating in anti-clockwise direction. Let's just turn the fast mode on so we can understand the operation. In this way we can control the operation or movement of the stepper motor and achieve whatever step sequence we need and rotate it. The next application is water level controller using PLC. So we have made an add-on board for water level controller. It includes a higher level sensor, lower level sensor, water pump, we have provided an banana connectors onto the add-on board so that we can connect it with the main board. The water pump we have used is of 5 volt operated, so we will connect a 5 volt DC supply which is provided onto the board through the relays to the water pump so that it will operate. We will connect sensor output to the input pins of the PLC so that the signal is given to the PLC, and as per the sensor inputs it will operate the motor or turn off the motor. We will connect lamps in the system also so that it indicates whether the motor is on or off. So for that purpose we will connect two lamps in the system. Let's just connect the inputs to the input pins of the PLC. This is the lower level sensor input. We will connect the supply pins required for the motor. I have connected the common pin, and the main supply pin is going to be connected through the relays. So I will connect this supply positive to the relay and motor positive to the relays NO pin. We will connect an start switch also, so whenever the start switch will be turned on, then after that only the system will start its working. I will turn on the start switch now. As soon as I turn on the switch, the system starts. There are two sensors, upper level sensor and lower level sensor. When water is at top, the upper level sensor is at high and lower level sensor is also floating on upward direction. So high level lamp is on. As soon as water level decreases, upper sensor will come down like this, and when water level furthermore decreases, lower level sensor will also come down, and as soon as it touches low level, the lamp and the water pump will turn on. It will remain on until and unless the water tank gets full. So as water level rises, the lower level sensor floats high, and also the higher level sensor will also move toward the high. As soon as it touches the high level, the sensor will detect that, PLC will act on that and turn off the pump as well as turn on the high level lamp. Again, when water level decreases, low level sensor activates, the lamp will turn on and the water pump will turn on. Again, water level rises to the top, the lamp of top level will on and the water pump will turn off. As soon as we turn off the switch, the system will stop its working. The next application is elevator using PLC. So we have developed an add-on board which is having a prototype model of elevator lift. As you can see in the system, there is a model, and on that model we have given banana connectors to connect the add-on board with the main board. The motor provided in the elevator is DC, so we will connect 12 volt DC system supply to the motor through the relay so that we can rotate the motor in clockwise and anti-clockwise direction so that the lift can go up and lift can go down. Next we will connect the sensors. We have placed two limit sensors at the top and at the bottom of the lift model, so we will connect that output of the limit sensors to the input of the PLC. Next we will connect the sensors which I have placed in the system. One is the button for the door open close, so we will give the input of door open close through the switch. Two switches for the first floor and ground floor. So I have made all the connections. This is the top limit switch to sense the first floor. There is another limit switch as the bottom of the lift is used to sense the ground level. As soon as the switch gets pressed because of the lift at that location, it will sense. There is a sensors, 2 switches for first floor and ground floor, and 1 toggle switch to indicate that the door is closed or open to give the input to the PLC. Let's turn on the system. It is showing that the lift is at bottom, so bottom indicator is turned on, which is blue. I have made the connection to the indicators also. Lift is at bottom. We need to move the lift to the first floor, so we need to place the first floor switch. Before that, we need to close the door switch, and I will now press the first floor switch. Now the lift is started to moving upwards. I will just fast forward the video so that the process will become fast. Lift has started moving upwards, and the down indicator, that is ground floor indicator, is also turned off. Now lift is moving towards the first floor. When it will reach the first floor limit switch will get pressed, and the sensor will give the input to the PLC, and the lift will stop over there, and the lamp will glow of first floor. See, as you can see, it has reached the top and the lamp is turned on. I have opened the door that is indicated by the switch. I have pressed the switch. Another person is entered, close the door and press the ground switch. So now lift will come down. Indicator has been turned off now. Lift has started moving towards the ground floor. As soon as it reaches to the ground floor, the limit switch at the bottom will get pressed, and PLC will know the status of the lift, and it will stop the lift. As you can see, now lift is going to approach at the ground floor, and the switch will get pressed, and PLC will detect that and stop the motor so as to stop the lift. You can see the indicator of the ground floor has also been turned on, and the motor has been turned off. If you find this video interesting, please hit the like button and share the video as much as you can. If you are new to the channel, please subscribe the channel. I will see you in the next video. Till then, take care and bye bye. Jai Hind.